this lesson, we will cover the critical points, tangent equation, limits, and continuity. How to use limits to find derivatives. Now the rule says for function f of x, the first derivative f prime of x equal limit fx plus h minus fx divided by h as h goes to 0. Example 1. Use the definition of limits to find the derivative of radical x. First of all, I want to give you a tip. Radical x is basically x to the power 0.5, and if you know the basic rules of a derivative, you will discover that f prime is 0.5 x to the power negative 0.5. Now, we want to apply the rule, thus we have to write it first of all. We will substitute, thus we will say, okay, limit radical x plus h minus radical x over h. Now, because we have radicals, we will go to the conjugate rule to simplify the limits, meaning I will take this fraction and I will multiply it by the conjugate radical x plus h plus radical x divided by radical x plus h plus radical x. I will follow the rule of conjugate, which is a square minus b square. I will simplify it. I will discover that I will have h at the top and h at the bottom. They will simplify, they will delete each other, and the final shape will be after simplification 1 over radical x plus h plus radical x. Now I managed to get rid of h, thus I will substitute h, the remaining h, with equal 0, and I will find the limit. Another example, use the definition of limits to find the derivative of f of x equal x squared minus 2x. As a tip, if you know the basic rules of derivative, f prime of x is going to be 2x minus 2. Now, we will apply the rule which says f prime of x equal limit fx plus h minus f of x divided by h as h goes to 0. Now, we will substitute and simplify in the coming steps. Thus we will say x plus h squared minus 2x plus h, and I'm simplifying. You can see at the side how I'm doing this. Okay. Then I will go back to the rule. I will keep in mind that there is minus f of x, thus I need to replace it. Now you can see in the steps how I am breaking down the brackets. I am simplifying the shape. And you can see that at the upper part I have h as a common factor. This I will extract it out and delete it with the lower part. Then what is left, I will replace h equals 0. Just follow the steps. I want to highlight the relationship between continuity and differentiability. I want you to pay attention. Now, having a function that is already differentiable, f of x is differentiable at x equal a, it means definitely that fx is continuous at a. Take it as a rule. Now, the opposite, you have to be careful, meaning that if f of x is continuous at x equal a, it doesn't mean necessarily that it will be differentiable. Now, if it's differentiable at x equal a, then it's continuous at x equal a. Now, continuity doesn't mean necessarily differentiable. Thus, if f of x is continuous at x equal a, it doesn't mean that you have f prime of x at a. Places where we don't have the first derivative for f of x. Any point with vertical tangent definitely will not have a derivative. Like here, can you see at x equals 0 at the origin you have a vertical tangent, and accordingly there is no first derivative at this point. Now, points with vertical asymptote, and I could say that with infinite discontinuity. When you have an infinite discontinuity, it means you have a vertical asymptote, and at this point you don't have a derivative. Any point with jump discontinuity means that there is no derivative at this point. Also, any point with removable discontinuity with a hole means that also there is no first derivative, or there is no derivative at this particular point. How to find the critical points and the maximum and minimum values? Now, to find the critical point, you have to take the function and find the first derivative and make it equal 0, or you said, okay, f prime x at this point is undefined. Now, take the following example. Now, to find the first derivative, we will discover it is minus 2x. You will make it equal 0. When you solve it, you will discover x equals 0. Now, in order to find the critical point, take this x equals 0 and replace it back in f of x. If we do this, you can see the critical point is 0, 2. Now, how to decide the increasing interval and the decreasing interval, in addition to that, the maximum and minimum if we have. Now, you have to graph a number line. In this number line, at the left you have negative infinity, at the right you have infinity, and in the middle the critical or the x you found it. You use f prime or the first derivative to test. Now, we concern with the sign. Thus, I want you to watch how I'm deciding the signs of the number line. Now, we know that if it's positive, it means increasing, and it will be negative infinity open to 0 infinity. Now, when it's negative, it means decreasing, and it will be from 0 to infinity. You can see that at x equals 0, we have a maximum value. Thus, we will say the maximum value occurs at x equals 0. Okay, I'm going to repeat the example. And this time I want you to find the critical points, increasing, decreasing intervals, and maximum and minimum. First of all, we will find f prime, or the first derivative of x, which will be negative 6x squared minus 18x minus 12, and I will make it equal 0, and I will solve it, and I will find the values of x that fulfilling this equation, f prime x equals 0. Now, if I do this, I will discover that I have two values for x. And you can use calculator or the basic factoring to find the values of x, and they are x equal negative 1 and x equal negative 2. Now, I will graph now a number line containing x equal negative 1 and x equal negative 2, and I will keep in mind that to the left I have negative infinity to the left of the number line, and to the right I have positive infinity. Now, I will use f prime x for testing. I'm going to select random values in the three intervals you can see, and I will decide the sign as you can see in front of you. Keep in mind, whenever you have negative sign, it means decreasing, and whenever you have a positive sign, it means increasing, meaning that I have two intervals, decreasing intervals, which are negative infinity, negative 2, of course, open, and negative 1 infinity, open. And I have one increasing interval, which is from negative 2 to negative 1, and it's, of course, an open interval. From the shape, I know that I have a minimum value at x equal negative 2, and I have a maximum value at x equal negative 1. Now, I want you to pause your screen and solve this equation, then compare your answers. In this section, we will highlight how to write the equation of a tangent line for a given graph. Okay, to find the tangent line, we have to do the following. First of all, when he gives you x equal a, you have to replace it back in the given function so that you will find the f of a, and you will have the point a, f of a. Now, you will differentiate f of x, and you will substitute a inside it so that you will have the slope. Finally, you have a point and you have a slope. You will use the equation line y minus y1 equal m times x minus x1. Okay, find the tangent line equation for the given graph at x equal 1. The first step, we will replace x equal 1 inside y. This we will say negative 3, 1 to the power 5 minus 8 times 1 to the power 3 plus 4 times 1 to the power 2, and the answer will be negative 7. Thus my point that I will use is 1 comma negative 7. Now I will differentiate y to find the slope. Thus after differentiation, y prime will be negative 15x to the power 4 minus 24x squared plus 8x, but I will substitute now x equal 1. Thus my slope after substituting will be negative 31. Now I have a point which is 1 comma negative 7, and I have a slope negative 31, and I will say I'm going to use the equation y minus y1 equal m times x minus x1, and then I will simplify the equation to the end. Last example, find the tangent line equation for the given f at x equal to 3. First of all, we replace the value of x equal to 3 inside f of x to find y, which is 2. Thus we are dealing with the point 3, 2. Now, later we will differentiate fx to find the slope. Thus f prime x is going to be 4x minus 7. I keep in mind that I'm dealing with x equal to 3. Thus I will replace it to discover that the slope is 5 basically. Now the last step, you will say I'm going to use y minus y1 equal m times x minus x1, and I will replace all the values and simplify and finish the question. Now that was the end of the lesson. Thank you for watching.